So in this video, we're talking about the parallel lines practice assignment this day that I was absent. So the first thing we want to understand is how to graph a line. So far, I've only given you guys one form of an equation. It's this one. It's called the slope-intercept form. A lot of students just know this as y equals mx plus b, okay? But you need to know the word slope-intercept form because that vocabulary is contained inside of it. So the reason why we call it slope-intercept form is because the m, that value represents the slope, all right? And the b, this number right here, represents the y-intercept, okay, which is where the line would cross the y-axis, okay? So when we have our lines, we want to graph them. We want to understand what they are, okay? So we need to know all the pieces of the equation. The first thing that we could do, if I wanted to graph the red line that we have right over here, right? We see that it says that y equals -2. You see that? So since y equals -2, we should understand from our last couple of units that this is a horizontal line, okay? And every point on this line has y equal to -2, and that's why we call that the line y equals -2, okay? So when we solve a system, right, we're looking for some numbers that make both of these equations true, right? We want some numbers, x and y, that if I find them, it makes the red equation true, and it also makes the blue equation true, right? That's what we're trying to find. So the way we could do this by graphing is by looking at the place where our lines cross. If I find a place where the red and blue line cross, then that's the solution of the system, right? That's the one that'll make both true. So I did the red line, right? So now I got to do the blue line. Okay, so to do the blue line, we're going to decode what this whole equation is supposed to mean, right? So we'll copy it underneath that we got x plus 1. Okay, y equals x plus 1. Well, again, the slope is the number that is in front of x, and we should see right here there's nothing, okay? So one job you guys have as freshman math students is to know that when we have a variable with nothing in front of it, it's an invisible one, okay? We just don't write it all the time, all right? So we have to know the slope in this case is 1, right? And then we'd have to know that the y-intercept for this example right here, right? The y-intercept is 1 also, okay? So that's what we got here. So the y-intercept, what that means is this is where the blue line crosses the y-axis, all right? So that means it crosses right here at that place, so I go put a dot there. That's the way we start these problems, okay? But then we got to remember a little bit about slope, right? We know that m was our slope, okay? But on top of knowing the word slope and knowing that m is the slope, you have to also remember that slope is our rise over run, okay? So when I have a value like 1, we have to be able to understand that 1, I have to turn that into a fraction so that I can really work with it, right? We need something to look at, something to move, right? Well, what do I put? It's 1 over 1, right? Now that I have my rise over my run, we could probably understand how to do this problem, right? I go to my point, right? And then I'm going to go over 1 and up 1. Over 1 and up 1. Over 1 and up 1. And I just keep putting my points there. So we'll do those points in blue, okay? And again, I start at my y-intercept, and I go over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1, okay? And then when I run out of space, I just go backwards to continue the pattern, okay? And then we can connect all the dots, and it should be a straight line. Again, we're starting to see that that's what makes a straight line, is that it always goes up and over the same amount, right? If it changes the amount it goes up, we're going to see the line is no longer straight. It'll be broken. Okay, so in this case, we see this point where the lines cross, right? They cross right here. We could call that point A if we wanted. And this point A is the solution, okay? But the solution in this case is this point, right, that has an x-coordinate of -3 and a y-coordinate of -2. Okay, so we can see that this point does make those two equations true, both of them, okay? I'm going to go do that right now for the sake of being complete with this problem, and then after that, I'm going to maybe quickly do a couple of those problems, and then the purpose of this video is mainly going to be to do the parallel line calculation, so we're going to move on a little bit in our process, okay? So like I said, we want to make sure that our point A equals 3, 2, right? Does this make both equations true? Does it make the red one true, and does it make the blue one true? All right. Let's go verify that it makes it true. Well, we can see that this point has a y equal to, sorry, negative 2. I messed that up when I wrote it in here. It's a negative 2, right? And a negative 3. Okay, so we know that this one, right, definitely makes that true because y is equal to negative 2. You can see it. Okay, but now what we want to check, is it true that these two numbers make this thing true, right? So tell me, what do I plug in for x? Well, notice that x is equal to negative 3. So I have to put the negative 3 on this side. Okay, and because y is equal to negative 2, I want to put negative 2 on the other side right here. Well, let's check if this is true. Is it true that negative 2 is equal to negative 3 plus 1? Well, negative 3 plus 1 is equal to negative 2, right? So this is true, okay? And again, this one is true. And why is it true that y is equal to 2? Well, because we looked at it right here. Look, y is equal to negative 2 for this point. All right? Therefore, A, the point A, 3, 2, is the solution to the system. Okay? Now, I'm going to say we didn't have to name the point. I've been naming points lately because that's just something we've been doing a lot of, but I don't have to give it a name. All right, we use a letter because it could be easier to just call it A, B, C, D instead of having to talk about numbers all the time, right? So again, the coordinates are negative 3, negative 2, and look, I did it again where I forgot to include the negative, so those negatives should be there, so sorry about that. So that's how you solve this system. All right, we just drop the two lines down, and we see where they cross, and that's the answer. Okay, all I did over here was just my double checking. This was just me checking to see that it makes this true and this true. And I'm telling you this so you guys understand that's what it means to be a solution to a system of equations. Right? It makes both of the equations true. It makes all of them true. Okay, so we could do this one here. And then after this, we'll jump into the algebra problems. All right, so the first one, working with this one in blue, I'll start with my y-intercept. I'll go to minus 3. And then I'll consider my slope, right? If my slope is negative 2, then that means my rise over my run is negative 2 over 1. So that means when I go over 1, instead of going up, that means I have to go down 2. Right? So I'm going over 1 and down 2. But you can see I'm out of room, right? I can't go over and down anymore. So what we see is I have to go backwards now. Right? So you just have to get a feel for the way these problems do. This pattern, okay? Again, so now since I can't go down and to the right anymore, I have to go back. And just continue the pattern. You can see that, you know, if I continue that pattern, I'm going over 1 and down 2. And that would be correct. So now if I just connect this line using a straight edge or something, it should be really good. And it can help you calculate the answer here. Then we'll do the next one in red. Okay, so this tells me my y-intercept is 3. So in this case, I'm going to start at 3. And then my slope is telling me that it's over 1, up 1, right? So I got to go over 1, but then up 1 because that's positive. Okay, so again, I'm out of room. So that means I got to go backwards. Okay, and we can see where they're going to cross right there. Okay, so I can connect those points, and we see, hey, they cross in this little spot right there. Okay, and the coordinates of that point, what's the coordinates of that point right there? Well, we see that it's negative 2 and positive 1, right? Maybe you can see why I gave the point a name now, right? Because it's so hard to write that in there, yeah? So I'm gonna give it a name again. So I think that was a good habit. Okay, so we'll go ahead and call that point A. Okay, and again, the coordinates of A are negative 2, positive 1. Hello. Right. We're good? Yeah. Gotcha. Yeah, so that's the solution. Okay, sorry about the phone call, guys. So now what we have going on is to prove that it works. Again, we could do this. Okay, to do that work, what I would do is say, okay, does it make this equation true? Right? And does it make the other equation true? Okay, if we did our work, we'll find out that those x and y values, right? Negative 2 for x, right? And then y is 1. That'll make both of these equations true if we plug them in. Okay, so I'm going to spare you guys the explanation, but you can verify that on your own as an exercise. As long as we didn't make a mistake, that should be the answer. Okay, it should make both of them true, and that's our solution. So now what we're going to do is jump into the part on the back. All right, and if you guys were good at graphing, maybe you skip straight to here, and so that's fine with me. Let's try to leave it about that size. I hope it works. Okay, so for these problems, we'll start to get a good list of how to do them. Okay, the first thing is to understand what is slope-intercept form. So my first step for these problems is usually to write the correct form. Okay, make sure that you understand which form we need. In this case, we need y equals mx plus b. So I'll write y equals mx plus b. Okay, and the reason why I know I need that form is because it tells me right here. It says, which form do I use? The slope-intercept form. Okay, and that's y equals mx plus b. After we get the correct form down, then what we want to do is we want to read the problem and understand what it says. This says that we want to find a line that's parallel to our given line, right? And so now I've been telling everybody when I walk around, that's why I did this in class one day. You guys probably thought I was crazy because I was saying parallel lines have equal, and then I wanted everybody to say slopes all at the same time, right? And I try to make you guys say it loud so that I could walk up to you at any point for the rest of the year and say parallel lines have equal, and you would know to spit slopes back at me, right? So parallel lines have equal slopes. Okay, we're going to write this in all caps. And I hope you guys understand this is a great big idea of last week. Okay, so this is already review. It's already old news. Okay, parallel lines have equal slopes. So now what we're going to look at is the third step, right? But before we get there, actually, what we should do is start copying some work. So we know that the slope is the n. And because parallel lines have equal slope, I'm going to copy that number. So all I copy in the first step is m. Okay? So since parallel lines have equal slope, that means I copy the slope. Okay, so look at the only thing I changed, right? I copied everything from y equals mx plus b, but I only changed the m. You see that? Okay. Then after that, now we have to do what's called substitution. So at this step, we're going to substitute x and y. And those come from our point. So my x and y are right here. Okay, so what's going to happen is when I go substitute in x, okay, what I teach my students is anytime we're substituting, you probably want to turn x into a blank parentheses to avoid trouble in the future. Okay, it's just a better habit to have. So in this case, I'm changing the x with a blank parentheses. But if you really listen to what I said, then I'm telling you, every time you substitute, we put a blank parentheses. So technically, I could put on the left side too, all right? But it's not that important in this case. So anytime we substitute, we make the blank parentheses and we go put our numbers in there. Okay, it says substitute x for x. So again, x is 4. So where do I go put that? Do I put that here for y or here for x? Well, obviously I put x for x. So just try not to get thrown off. In fact, I'm going to make a mistake right now like I did in class on purpose so you guys can see this, okay? In class, I went like this on purpose. You can see this is wrong. Do not write this. What's wrong with this? I hope you guys see, right? I put the 4 on the left because it's left over here. And I put the negative 1 on the right. But that's not what this says to do. This says that y should go right here. And y is equal to negative 1. It's not equal to 4. So 4 should not go there. What has to go there is negative 1. Okay? X is equal to 4. So, you plug in x for x and plug in y for y. Alright? If you get real trouble, you might want to add that into this step, right? Plug in, right, x for x, okay? And plug in y for y and so on, okay? You understand? That little step is really important that you get that right. Okay, we did this in class where we simplified it. So I would say when you do a number times a fraction, that means to do the number times the numerator, the number on top. So we do 4 times 3, that makes 12. So we get 12 over 4 plus b, okay? And since negative 1 is in the parentheses and there's nothing else, I can just get rid of the parentheses now. And so we have negative 1 right there. Okay, we're going to have to do a little bit of the algebra with this things right here. So I'm gonna erase that just for the sake of making some room. And I'll push everything up. Again, I hope you guys see that we have to reduce this fraction, right? 12 over 4 is equal to 3. 12 divided by 4 is 3. Okay, if you're having trouble with fractions, that could be something you come talk to me after school. That'd be a great thing to bring after school. I can give you some resources. We make sure that fractions are no longer something you're weak at. Okay? And then you got, less trouble. One less thing to worry about when we get here. Okay? So if I subtract 3 from both sides, we get to the last step. It tells me that b is equal to -1 minus 3. And that makes -4. Okay, I'm sorry that we're working so small over here. But that's the final answer. So after you get this, after you find that last number, what did we just do? Okay? Well, really, what we did was we solved for b. So that's why I got to teach you guys algebra, because it's important that you're able to solve for b to solve this problem. Okay, so we solved for b. And the last step of these problems is to go substitute in b, right? So we plug it in. So think about it. We have y equals mx plus b. But we're trying to figure out what this number is. But now we know what it is. It's this, right? The value is -4. So all I'm going to do to finish this up is over here in this last box, okay? We're copying everything that we had, the 3/4 x, right? But check your understanding. What do I write to finish this problem? What do I have to do, right? Well, instead of writing plus b, I'm going to go use this number that we got. We have -4. And so that's the way to complete this problem, okay? And so really for this last thing, we're going to plug in b, okay? Plug in b to our y equals mx plus b equation, right? You got to go add that slope, right? So there you go, okay? This is the way we do this. I did number 8 and 14 in class, so I'll probably do a different example in the video so that I cover everything. So if you come to class today, you'll see 8 and you'll see 14. And so we'll go do number 9. Alright, so again, working through a little faster. These problems don't have to take so long, so when I'm teaching you, I always go slow. But the first step, again, is to copy y equals mx plus b. The reason why I did that is because it tells me to. It says we need slope-intercept form, so I'm going to make sure I know, okay, I got the right form. Then we got to remember parallel lines got equal slope, alright? I hope even if you're sitting at home, you said that. Parallel lines got equal slope. We want to memorize that, okay? It can't be something confusing to us, right? We know parallel lines got to go the same way. Slope basically means they're going the same way. So at this point, we got our slope copied, and now what we do is we go substitute in our x and y, okay? So we want to make sure that the x goes for x and that the y goes for y. So that means, check me, work ahead, like check your understanding rather, check you, right? Where does the x go? Where's the y go? Put me where you think, where do they go? Put them. Okay, what happens is the -1 goes right here, because -1 is x. You see that? So that one goes for x, and the one that's y goes in for y. Okay, so to finish this little algebra problem, we got -3 times -1. That just makes 3. Okay, right? A negative times a negative is a positive. So I have 3 plus b equals 0. So I mean that means that b must be -3, right? Take away 3 from both sides, and we'll see, yeah, that's true, right? b has to be equal to -3. So what do I do with that, right? After I get this number, what was the whole point of that? Where's it go? Okay, we take that number and we plug it in right there. I hope you guys can see. Okay. Instead of writing y equals -3x plus b, now I'm going to write y equals -3x minus 3. Let's add that number. Alright, so better leave a couple of them for y'all to do. But I will do number 10, and I might put some answers so that way you guys can at least see what the answers will be. You guys can ask me some questions if you're stuck, right? So let's do one last one, and then I'll stop the video there. And then, like I said, I will do, I'll give you guys the answer key at the end for everything. So stay tuned for that. All right, again, slope intercept form. That's what it says. All right. So far, that's the only one you're asked, but that's not going to be the case in the future. Pretty soon, you guys are going to have to know the other forms of equations. You guys are going to make slides, and you're going to go around the whole planet Earth with that, you know. So for now, we know it says parallel. Parallel lines have equal slope, right? So that means I'm going to copy my slope. So you better know what the slope is. The slope is the number that's multiplying x, right? The number that we're multiplying with x. So in this case, I see negative 1 over 5x. Copy everything else, right? Okay, so I copy the slope. Now what I'm going to do is go use my x and y. In this case, look, it looks like x and y happen to be the same number. So it looks like in this case, you really can't mess it up, okay? But you do want to watch out about the parentheses. So let's make sure that in here we put -3 in the parentheses. On the other side, like I said, we can put it in the parentheses or not. It doesn't really matter, so you'll see why I didn't put it. But usually when you substitute, it's a great habit to have the parentheses because it'll stop you from making little errors when you're reading the problem. All right? So again, on the left side, -3 in parentheses is just -3. But on the right, we know that this means to multiply, right? And so I'm doing a negative times a negative, so that makes a positive, right? And I got to do this times the top, right? So a -3 times -1 makes +3. So on top I got +3 and on bottom is 5. That didn't change. Okay, so now this is all equal to b right here. I'm sorry. -3 is equal to 3/5 plus b. So now I want to get b. I want b equals, and I want to push that 3/5 to the other side. So that means I have to subtract 3/5 from both sides, right? So I'm going to shrink this down a little bit so that we can get through this. Keep that lined up, I guess. All right, so I have to subtract 3/5 from this side and 3/5 from the left side of the equal sign, right? So now on this side I got b, but over here we have to have the result of -3 minus 3/5, and that might not be something that everybody could do. So we're gonna press pause for a second. And before we go write our answer, I hope you guys could stay with me and understand what are we doing to solve this problem, right? All I want is my y, right? I know I'm going to get 1/5 x, right? -1/5 x. And I want to know what number goes right here, right? I want to figure it out. But to do that, I have to finish this calculation, right? We got to do -3 minus 3/5. So we'll do that in a new little tab. And I'm going to try to save this. I'll probably have to make a new tab to save it one more time. Sorry about that. Oh my God, it went away anyway. Okay, so now we're going to do -3 minus 3/5. All right, so -3 minus 3/5, okay? The way that I teach to do these calculations, you put an equal sign, and then what I usually say is leave a little bit of empty space in between where I'm going to do the -3 and this one, okay? And the reason why I'm doing that is because what I have to do is, in parentheses, I'm going to multiply this by 5/5, okay? So think about what I did. Like, all I did is copy what I had, but I just left a little bit of empty space right here in between the equal sign and the -3 so that I could add that little thing that I'm multiplying, okay? And we'll talk about why I did that, okay? Now, I'm going to do -3 times this, and let's see what changes about it, right? Again, we said a number times a fraction means you do the number times the top, right? So negative times a positive makes a negative. 3 times 5 is 15, okay? Nothing changes on the bottom. For a lot of people, this makes sense that I say, okay, it's -3/1, right? We do the top times the top and the bottom times the bottom, right? 5 times 1 is 5. Okay, but really, the answer is a little bit more deep than that. It's not really just because it's over 1 or something. All right, so anyway, the next thing that we talk about is -3/5, right? That part over there that we already have. We just continue doing our math now, right? So this thing right here changed into this, right? But the -3/5 didn't change, so that's right there, okay? So how do I do this, right? What's -15/5 minus 3/5, right? Well, because they have the same number on bottom, that means I can combine these into one fraction. So what I have on top is negative 15 minus 3. Okay, so we do that together, and that's why fractions become annoying, because the numbers are more complicated, right? We have to deal with the top and the bottom. Negative 15 minus 3 is just negative 18. Okay, and the 5 doesn't change. That stays on bottom. Okay, so this would be the value that you need. This is our b value. We're going to go add negative 18 over 5 to this place right here, right? This is going to be negative 18 over 5, all right? Because that's what this was. So when I finish my work, we see that b is equal to negative 18 over 5. That equals b. Okay, so yeah, fractions will be annoying. You guys will have to, deal with it. I'll make a little video to make sure that we can help everybody catch up. But it is, it's old math, man. That's 6th grade math, so we got to brush up if you need to. But just understand, it's not going to go away just because you don't like them. All right, so you guys got to learn those. So good luck. Like I said, I will show the answer key. So, make sure that you learn something. Don't just copy everything. Put the answers you got right here. Okay, we got our solutions, and we got our equations that we need for our parallel lines right here. So I'll post this video right now. I hope this helps people. If you missed the day on Friday, that should be a good review. All right, good luck, you guys.